Hey guys, so welcome back to part 2 of 8.8c, where we are still representing equations using algebra tiles, and we are understanding how to solve equations using the inverse operation and isolating the variable. Today we're going to be able to model and solve equations with one variable on both sides of an equal sign arising from a mathematical and real-world problem. Okay, so yesterday we focused just on modeling the equations and solving, and today we're going to add that last thing in where we're going to be solving real-world mathematical problems. So just a quick review, positive and negative algebra tiles. Okay, the green and the x are the positive variables with the units being 1, and the negatives are the red tiles with the negative x and the negative 1. Again, zero pairs is when you have a positive and a negative, either variable or a positive and negative unit, and together they create that 0. Okay, so here we're given a statement, and then we're going to write the equation that goes with that statement. So this is kind of tying in what we were focusing on last week. So as we read this statement, it says the difference of 3 times a number and 7 is the same as twice a number and 5. So again, where it says the same as, okay, this is where our equal sign is. Okay, for some reason that's not working. Oh. So we're gonna, okay, same as, that's our equal sign. So that splits the statement up into two parts, the left part, or the left side and the right side. So the difference of 3 times a number and 7. So difference, again, is associated with subtraction. So 3 times a number, okay, so 3x and 7. And again, we said the operation is subtraction because of the word difference here. Okay, the right side says twice a number and 5. So twice a number means 2x. And 5, again, is associated with addition. So our equation for this statement is 3x minus 7 is equal to 2x plus 5. Now, that's what we did last week. To tie in what we're doing this week is we are now going to model this equation, this 3x minus 7 equals 2x plus 5 with the algebra tiles. So I'm going to pull up this algebra tile board, and I am going to have it where it's solving. So our equation was 3x minus 7 is equal to 2x plus 5. All right, so to represent that, I'm going to represent the left side first with 3 positive x's. So 1, 2, 3. Okay, and then again, to represent the minus 7, I'm going to use the negative units. So 1, 2, 3, 4, 5, 6, 7. Okay, and if you notice at the bottom, I can ensure that I'm having the same 3x minus 7 and 3x minus 7. On the right side, it says I'm going to have 2x, okay, plus 5. So I'm going to represent that plus 5 with the positive units, 1, 2, 3, 4, and 5. Okay, so now I've modeled my equation. Okay guys, so since I know we don't have algebra tiles at home, even if you wanted to model this, you could quickly just sketch it out. So we're going to use this space, so I'm going to make this kind of like our board that we have. Okay, and on the left side we have 3x minus 7, so you can easily just take 3, 1, 2, 3, and even if you don't have color, you can just put positive x's. Minus 7, so I'm going to draw 1, 2, 3, 4, 5, 6, 7. So this is a quick way just for you to sketch what the problem looks like. 2x on the right side, so we get 2x. Okay, and then plus 5. So 1, 2, 3, 4, 5. And you could even put like plus signs in these. Okay, and if you wanted to represent the negatives, you could just put a negative sign in here. Okay, so that's a quick way to do that at home to represent the equation. Now let's get back to the tile so we can solve. So again, our job oh man, is to isolate the variable. So sorry about that, guys. Quickly get this back here. 1, 2, 3. Oh no, that was the wrong one. 1, 2, 3, 4, 5, 6, 7. All right. And then on this side we had 2x plus 5. 1, 2, 3, 4, 5. Okay. So again, we want to isolate our variable, meaning we want to get all the variables to one side and to get all the constants to one side. So we're going to use some inverse operations. So here I have 3x on this side and I have 2x on this side. So I'm going to go ahead, since I have 3 is larger than 2, I'm going to use the inverse operation to get rid of the 2x first, or subtract. Again, they're starting out positive, so to do the inverse operation of addition or positive is negative. So I'm going to add -2, and if I add -2 to that side, I'm going to add -2 to this side. And once I don't know what happened to that one. Once I've added them to both sides, guys, then you can create your 0 pairs, where therefore these cancel out. Now again, I still don't have x by itself yet. I need to get rid of this -7, but again, I can't just get rid of them. I can't just erase them. I have to do it mathematically. So I need to add +7. So 3, 4, 5, 6, 7. And again, the reason why I'm adding 7 is because to get rid of the -7, I need to add 7. And so if I add 7 to that side, I'm going to have to add 7 to the right side. So 2, 3, 4, 5, 6, and 7. And then here I can create those 0 pairs, because again, we have, all right, so now we have x over here, and x is equal to 1, 2, 3. It tells us, down here it says x is equal to 12, all right? So, but again, we're not done. We want to make sure that we're plugging it into our calculator. So I'm going to go back here where we have said that our solution is x equals 12. But again, I want to make sure that's 100% correct. So in my calculator, what I'm going to do is I'm going to plug in each side of the equation and substitute x for 12. So we're going to start with the left side first. So I'm essentially saying 3 times 12 minus 7 equals 2 times 12 plus 5. So 3 times 12 minus 7, okay, gives me 29 on the left side. And if these are equal, I should also get 29 on the right side. So 2 times 12 plus 5. And yes, I get 29 on both. So x equals 12 is my solution. All right. Okay, so let's go ahead and work another one. All right. Example number 2. 4 times a number minus 5 is equal to the difference of 3 times a number and 1. So again, we want to find where it splits the 2 into 2 separate sides. And it says equal to, so that's pretty clear where it divides the left and the right. The first part we want to read is 4 times a number minus 5. All right, guys, so 4 times a number, I'm going to use z this time, minus 5 is equal to, and now I'm going to look on the right side, the difference, all right, so I know I'm going to be subtracting the difference of 3 times a number, so I know that's 3 times a number, and 1. All right, so my equation is 4z minus 5. Oh, you know what? I'm going to make that a little, I'm going to change this variable, guys, because I don't want it to get confused with a 2. So I'm going to here put x. So 4x minus 5 equals 3x minus 1. All right, and if we were to draw this, again, we could represent it with the tiles. 4x would just be, again, 4 of the long ones, 2, 3, 4, and then minus 5. So that minus 5, I would represent those with negatives. 1, 2, 3, 4, 5. So that's the right side. The left side, 3x okay, and then minus 1. So again, I'm going to have this minus 1 here. Okay, and your drawing doesn't have to be perfect, guys. It's just a quick sketch for you to visually see what this problem is saying. So we're going to come to our tiles here. I'm going to clear this, put this board back. Okay, so our equation was 4, oops. Our equation was 4x minus 5 equals 3x minus 1. All right, so I'm going to represent that with the tiles. 1, 2, 3, 4. All right, so I have my 4, and I can put those kind of like that. Minus 5, 1, 2, 3, 4, 5. Okay, now to the right side, 3x, and again, I'm using the green x's because the 3 is positive. All right, minus 1, so I'm going to represent that with that -1 tile. Okay, now again, I want to get all my x's on one side and all my constants on another. So right now, I'm looking at 4x and 3x, and since 3x is smaller, I'm going to subtract that from the right side first. In order to subtract it, okay, I'm going to minus 3. So that's why I'm adding these -3 tiles. And if I do it to one side, I'm going to need to add them to the other side as well. Okay, once I've added them to both sides, then I can create the 0 pairs. All right, so I'm left with -1 on this side, and I'm going to create the 0 pairs here. And then I still have 1 x left on this side. But again, now I have x over here, but I still want to get rid of this constant, which is a 5. So in order to get rid of this minus 5, I'm going to add 5. 1, 2, 3, 4, 5. And if I add it to the left, I need to also add it to the right. 1, 2, 3, 4, and 5. Okay, and now since I've added it to both sides, then I can go ahead and create those 0 pairs. So where I finally have x by itself, create this 0 pair here, and I'm left with x equals 4. Sorry, x equals 4. But again, to be positive, I'm going to put it into my calculator. So we said our solution is x equals 4. All right, so I'm going to open the calculator. And I'm going to do the same thing. I'm going to plug in, I'm going to substitute 4 for the x. So 4 times 4 minus 5 is equal to 3 times 4 minus 1. So again, I substitute, where there was an x, I substituted a 4. So now to put it in my calculator, 4 times 4 minus 5, I get 11 on this side. And if I'm working on the right side now, 3 times 4 minus 1, and I get 11 on this side. Therefore, both sides are equivalent. They are the same. Therefore, my solution is x equals 4. Okay, guys, so what about if we wanted to solve equations where the numbers were a lot larger and we didn't want to sit there and add, let's say, 50 tiles or 100 tiles? Okay, so what do we do when our numbers are getting larger and larger, but we don't have enough tiles? So we are going to look at how to solve these equations without the tiles with just a standard mathematical format. So first things first, what we've been doing is we've been collecting the constants on one side. Again, the constants are the numbers that are standing alone, okay, by using the inverse operation. We've been collecting the variables to one side as well, okay, by using the inverse operations. And then we've been solving our equation for x. And again, we always want to keep in mind, remember your equation must always remain balanced. All right, so what would that even look like? What does collecting the constants to one side look like, or what's collecting the variables to one side look like? So we're going to work through an equation together. So we have 30 plus 3w equals 4w plus 22. Remember, the variable doesn't always have to be x. Again, a variable could be any letter representing an unknown number. And right now, our unknown number is w. So we are trying to solve w equals what right now? What number is it representing? So first thing I like to do is I like to draw a line down my equal sign, which just helps me remember that there are two sides of this equation. There's a left side with an expression and a right side with an expression, okay? So it just kind of helps me keep them separated. It also reminds me that if I do something to one side, I need to do it to the other to keep it balanced. So first things first, if we were to represent this with the tiles, we would want to look at the variables first. On the left side, we have this 3 plus 3w, and on the right side, we have this positive 4w. Okay, so they're both positive. Now, if I want to move the variable to one side, to collect them to one side, I don't want my variable to be negative. So I'm not going to move the 4w to the left side, because then that would mean I'd have to subtract 4, and then that would make my variable negative. So I do want to keep it positive. So since 3 is smaller than 4, I'm going to subtract 3. Sorry, let me erase that, put that back. I'm going to subtract 3 from the left side. Okay, so minus 3x. And again, this would be like putting down 3 negative x tiles to get rid of the 3 positive tiles. And if I do it to one side, I'm going to do this to the other side. So minus 3w. Now again, addition and subtraction are inverse operations. So what we're doing now is what those tiles were doing, is creating those 0 pairs. And I like to draw a big Z there to help me remember, oh, okay, it's not that they just went away, it's that they created 0 pairs when I combined the inverse operations, okay? Now, I'm going to subtract over here 4w minus 3w, so 4 minus 3 is 1, and the w remains, okay? Or you could just put that as w. I'm going to bring down this plus 22 because I haven't done anything, equals, and now I'm going to bring down this 30. Okay, now I still don't have w by itself. So now I'm going to collect the constants to one side. So to get rid of this plus 22, I'm going to do the inverse operation of addition, which is subtraction. So again, this would be the same thing as if I had those positive 22 tiles, then I would have to add negative 22 tiles to get rid of those, okay, for them to be canceled out. So if I subtract 22 on the right side, I also have to subtract 22 on the left side, again, to keep my equation balanced. And then again, we see that this plus 22 and minus 22 is going to create that 0 pair. Okay, so those inverse operations are canceling these numbers out. All right, so now I need to do this operation here, 30 minus 22. So I'm going to have to borrow. So 10 minus 2 is 8, and 2 minus 2 is 0. So 8, and now I'm going to bring down my w. And again, 1w is the same as just w. So our solution is w equals 8. But again, we want to check it. We want to be 100% sure. So again, I'm going to put it on my calculator. Okay. So here what I'm doing, guys, is I'm taking my solution 8 and plugging it back into the original equation to check my solution. And again, you always want to check your solution. So wherever I see a w, I'm going to substitute it with 8. So back to my original equation, 30 plus 3 times 8 equals 4 times 8 plus 22. So where there was a w, I substituted 8 to see if our solution is going to work. And now I just plug it into the calculator. So 30 plus 3 times 8, I get 54 on this side. Okay, so my right side has to equal 54 in order for my solution to be true. So 4 times 8 plus 22, and I also get 54. So yes, both of my sides are 54, so my solution for w is 8. All right. Okay, so let's work on another one. 25 minus 6n equals 8n minus 17. Okay, so again, I'm going to draw that line down to separate the left and the right side. Now here, I have 6n and 8n. And if I want to keep my variable positive, and again, n is just another letter, I'm going to add the 6n. I'm going to collect all my variables to the right side so it remains positive. So the inverse operation of subtraction is, hopefully you said addition. So instead of subtracting or having those negative 6n's, I'm going to add positive 6n to both sides. Okay, now again, this minus and this plus, okay, that creates that zero pair. Okay, all right, and now I'm going to do the math on this side. 8n plus 6. 8 plus 6 is, let's see, 8, 9, 10, 11, 12, 13, 14. So 14n minus 17 is equal to 25. All right, but again, I still don't have n by itself. So now I want to collect all my constants to one side. So now I need to get rid of this minus 17 by doing the inverse operation of subtraction, which is addition. So now I'm going to add 17 to both sides. All right. So again, then this creates that zero pair. All right, we have that big Z there. All right, and then 25 plus 17. That's 12, and I get 42 is equal to 14n. And again, I just brought that down. Now, 14 and n are held together by multiplication because they're side by side. 14 is the coefficient, n is the variable. Multiplication is holding them together. The inverse operation of multiplication is division. So now I want to divide by 14 on both sides. Okay, because again, to keep it balanced, if I do something to one side, I have to do it to the other. So, and again, I suggest here that you go ahead and get the calculator. Now, really quickly on this side, 14 over 14, guys, is just 1. Okay, that turns into a big 1. So now I just have 1n, or n, and now I'm going to do 42 divided by 14 to see what I get. So 42 divided by 14, and I get 3. Okay, so n equals 3. But again, I don't want to just stop there. I always want to check. So I'm going to plug 3 back into my equation, okay, and I'm going to check it with a calculator to make sure. So wherever there's an n, I'm going to substitute 3. So 25 minus 6 times 3 equals 8 times 3 minus 17. All right, so again, I have my calculator, 25 minus 6 times 3, and I get 7 on the left side. So let's see what I get on the right side. 8 times 3 minus 17, and I get 7 on the right side as well. So my equation is balanced, so my solution n equals 3 is correct. Okay, now that's a lot of information, guys. So I am going to leave you with an example. Okay, so let me see. Oh, I guess I didn't add that. Okay, so I'm going to put an example in the discussion, and I want you to go ahead and just solve for the solution and leave your comments in the discussion in Schoology. Okay, guys, again, make sure you're joining me for the lives at 9:30 and 2, especially with this equation stuff, guys. I know it can get a little bit kind of like muddled, and there's a lot of stuff to remember. So please, if you can, try to join me for the lives to get some clarification or just to answer any questions that you might have. So again, the question is going to be in the discussion. Make sure you leave your solution, and have a great day.